In this problem, we are asked to find the function of a third-degree polynomial when given the zeros of x equals -3, x equals 2, and x equals 3. All we have are those three values, and we need to generate an equation for that. It seems kind of crazy. How are we going to do that with just those three values? Well, zeros of a function on the coordinate plane are where that function crosses the x-axis. Y will equal 0 at those 3 points. So what we're doing is we're using that information to generate a function, and we will graph it, and I'll show it to you. So all we have to start with are these three zeros. So x equals -3, x equals 2, and x equals 3. Now, what we need to do is we need to set these equal to 0. So that would mean, as in this first example I've shown you here, because this is -3, we need to add 3 to both sides, and then we'll be left with this, x plus 3 equals 0. So similarly, over here, because this is a +2, to get 0 on the right, you would subtract 2 from both sides, and then you'd have x minus 2 equals 0. And over here, with this third one, you would subtract 3 from both sides, and you would get x minus 3. Now, why did I do that? Well, these are the three factors for our third-degree polynomial. So I'm going to go ahead and type those. So this is our function. F of x equals x plus 3, x minus 2, and x minus 3. So, okay, so what do we do with that? Well, you could take it just like that and graph it if you wanted, so you could see it. But we need to put this in the form of a third-degree polynomial. So I'm going to go ahead and multiply these together. And one of the best and quickest ways to do that, I'm going to go ahead and multiply this second one times the third one, and that will give me a trinomial, a second-degree trinomial, and then I'm going to multiply that times the first one, also using the box method. So remember that with the commutative property of multiplication, it doesn't matter what order you put the factors in. When you multiply them all together, you will get the same product. So I'm just going to go ahead and do these second two first. So it doesn't matter what order. So I'm going to go ahead and put x and -3 right here on the top of the box. And on the left side, I will put x minus 2, x minus 2. So now I'm going to go ahead and multiply and get the products for each of these, and then we're going to combine like terms, and then we'll have our trinomial. So that means x times x is x squared. X times -3, -3x. -2 times x is -2x. And -2 times -3 is +6. So now I'm going to switch colors, and I'm going to go ahead and write out the trinomial. And I'm going to start with the highest order exponent, which is x squared. There are no other x squared terms, so I'm just going to go ahead and write that, x squared. And -3x minus 2x equals -5x. So I put those two together. I combined those while I was going through. So again, -3x minus 2x is -5x. And then finally, we just go ahead and put +6. That's the last term. That's our constant term for that. So now we need to do the final step of multiplying that trinomial times the initial binomial. So we're going to do the same process, and then we're going to combine like terms. So I'm going to go ahead and set up another box. This one's going to be 2 by 3. And I think I'll switch colors. Oh no, I'll stay with blue. So I'm going to go ahead and do x and positive 3 on this side, x and 3. And then now I'm going to put this along the top, x squared negative 5x and 6. All right, so now we'll multiply these. So x times x squared, x cubed, or x to the third, negative 5x times x, negative 5x squared, 6 times x, 6x, x squared times 3, 3x squared, negative 5x times 3, negative 15x, and then 6 times 3, 18. Oops, ooh, that was messy. Okay, so I'm going to change colors yet again, and we're going to write these down. And remember, I'm only writing down the products. So I'm only going to write down the stuff here. And this will be our answer, and we can graph it. So x cubed. Are there any other x cubed terms? No, there are not. So we're going to put that first. We're using standard form. We're going to start with the highest level exponent. Now we have negative 5x squared and 3x squared, and that will combine to make negative 2x squared. And then we have 6x, positive 6x, and negative 15x. That will combine to make negative 9x. And then finally, plus 18. Okay, so what does that look like graphed? Well, let's check it and see. So you can see that right here, I graphed it, y equals that. And if you notice the zeros of the function, and by the way, the positive 18 is where it crosses the y-axis. That's your y-intercept. But these are the 3 zeros of the function. They cross the x-axis at negative 3, 2, and 3, just like it was originally specified at the beginning of the problem. So that's your answer. Great problem.